Hi guys, so today what we're going to be doing is we're going to be doing LeetCode problem 167 and we're going to be doing it in Java, and I don't like doing problems in Java because Java is a little bit difficult for me, but I think if it's broken down well, Java can be a great programming language. I like Python more because Python feels more like pseudocode. It doesn't feel like I'm actually coding, but we're going to just be doing it in Java because I'm going to force myself to do it in Java because I don't like Java. So, first look at the question. It seems like a lot, and I'm not going to sit here and I'm not going to read it, but I'm going to essentially just summarize the question for you. I'm just given an array list, and it's going to have integers, and we want to find two numbers that add up to 9. So we're just going to go down here to the test cases, and in this case, 2 plus 7 is 9. So we're just going to find the index of 2 and 7. And instead of returning 0 and 1, we want to return the indices, so we're going to do 1 and 2. So we're going to count from 1 instead of 0. And you're probably going to think, oh, I have to look at all the possible pairs. That's so many combinations. Like 2 plus 1, 2 plus 11, 2 plus 15, 7 plus 11, 7 plus 15, 11 plus 15, on and on and on and on. But just because the array is sorted, you can cheat a little bit. And instead of checking every possible pair like a caveman, you can just use 2 pointers, one from the start and then one from the end, and you can just work your way inward. And we call this the 2-pointer method. It's elegant, it's fast, and it's going to make you look very smart instead of testing every single case. So let me go ahead and do the code here. I'm going to explain it line by line. So this is our class, just the container for our code. And then this is just our function, and then it just takes the list of numbers and a target and then gives us back 2 positions. So we're not going to worry about these. What I'm going to do is I'm going to explain it like our left finger and our right finger. So since our list is increasing, but what I'm essentially doing here is to the left pointer, I'm assigning the value, I'm assigning the index 0. So since our list is increasing, the first integer in our array list is always going to be the lowest number since the list is already sorted for us. So let's say essentially like our left finger starts at the beginning of the list, and then our right finger is going to start at the end of the list, and that's going to be our biggest number. And see, numbers.length is just going to find the length of the list. It's not going to find the proper indexing. So if you have 31 things in your list, the last one is going to be index 30, just because when you're counting the length, it's not going to start from 0, it's going to start from 1. So what I'm going to do is I'm going to create a while loop, and I'm going to explain why we do this. So we keep looping while the left finger hasn't passed the right finger. So as long as our left is less than our right, we're just going to keep looping it. And why do we do this? Is if we cross, we've tried every possible pair and we can't keep going. But since we've promised that there is a solution, we'll definitely find that before it happens, because in the clauses it says that there's always a solution. And then essentially what we're doing here is we're adding both of the numbers at both pointers. So we're adding the first whatever number is at our index 0, and we're adding whatever number is at our last index. And we're going to do if sum equals target, return new. Essentially what we're doing here is we add the numbers at both pointers, and why we're doing this, we're checking, do these two numbers add up to the target? And if they do add up to the target, we found the answer and we don't have to do any more work. And obviously we're not getting the index, we have to do the indices, so we're just going to do 0. If like the index is 7, we're going to do 7 plus 1, and then if the index is 10, we're going to do 10 plus 1. What we're going to do is, obviously if that doesn't work, we're going to get out of this if statement and we're going to create an else if statement. So obviously if that doesn't work, we're just going to go outside of our if loop, and we need to make sure that we're going to be outside of that. Outside of our if statement, we're just going to do else if our sum is less than our target. So if our sum is less than, let's say like, if like 7, if we get 5 instead of 7 and our target is 7, we're just going to move to the next index. So we're just going to move our left pointer to increase to the left pointer forward. And why we do that is the only way to make a bigger number is to try a bigger number. And since the list is sorted, the next bigger number is going to be on the right. And then next what we're going to do is we're just going to create an else statement. So we're just going to do else. We're just going to do right minus. And what we're essentially doing is, if our sum is too big, we're going to move the pointer backwards. And why we do this is because we need a smaller number this time. And since the list is sorted, moving left means the number just gets smaller. And then we're just going to end our loop. And then we're just going to come here and we're just going to say return new second. This is here in case something goes wrong, and Java wants all its functions that say return to actually return something in every situation, even if it's never going to happen, because in this case, it's not going to happen. And why this entire code is going to work is because, let me make it bigger, and why this code is going to work is because the array is sorted, and that's the key, and it lets us make smart moves. So if it's too small, we can always try bigger. If it's too big, we can try smaller, and we avoid checking every combo. So we used logic this time. We didn't just keep checking and checking and checking and checking. We used proper logic. I don't know if I did a great job at explaining it. We're just going to run it and see if it works. And I got a compile error, and this was a quick syntax error. I just needed to add the comma there, and I need to add a comma here as well. Yeah, I'm glad I caught that. Ooh. And so that's correct, and our case is run, so we're just gonna go ahead and submit this. And yeah, if you guys need this breaking down even more, I can make another video. I'm not sure I did a great job at explaining it, but yeah, that's how it kind of works in my head. So yeah, thank you for watching.